And so, as always, and probably many of you have probably seen this before, but I always like to go over sort of the basics of what WWHM 2012 is trying to cover, and its uses and things like that. Something else to consider is we're hoping soon to have some form of an update for WWHM 2012. We don't know the specifics for that, but a lot of people asked about like rain gauge data, for example. Like, when are we getting an update for that? And hopefully that's coming soon. There's a lot of logistical difficulties when it comes to updating rain gauge data, for example, because when you update the rain gauge data, it also affects how previous facilities that were modeled now pass for certain stormwater events and modeling. Because if you add a bunch of data, because let's say you modeled like a pond or something based off previous rain gauge data going up to 2012, and so you modeled the flow frequency analysis and you model a pond based on that, and now you add another decade's worth of data to that. Well, the size of the pond may need to change now to meet your flow frequency standards. And so it's like, how, when do we add the data, and then how does it apply to previous facilities modeled? And so there's a lot of complications to that, and that's sort of why it's not so easy just to like every year update the rain gauge data, because like I said, there's a lot of complications involved. We're working on getting that squared away, hopefully soon, and getting a full software update, because it has been close to a decade, and a lot of people have been asking about that. But I guess my best answer is it's in the works. So that's what I would say. But yeah, I'm Joe Brasher Jr. from Clear Creek Solutions, and I'm running this live workshop. Please, if you have any questions, just put them in the chat, and I'll be happy to answer them. It's been a while since we've done a 2012 specific workshop, so it's nice to be doing one of these. We do have our courses, the WWHM 2012 Academy, of course, and other courses that cover WWHM 2012, but it's nice to be doing some free ones as well. So we're from Clear Creek Solutions. We do a variety of modeling and things like that. Like I said, we have some stragglers coming in as usual, a little late during their lunch. That's fine. If you have any questions, please put them in the chat. Okay. So I always like to talk about why do we use WWHM 2012? What's its purpose? So WWHM 2012 is a continuous simulation software package that models the entire hydrologic cycle. So one of the big differences that we like to think about in Western Washington is the difference between continuous simulation and single event hydrology, which are very different. So because of specifically the rain cycles that we get, or the type of rainfall we get here in Western Washington, it's very important for us to use a continuous simulation hydrology method. Because if we think about our rainfall patterns, I mean, of course, we're having a really good fall here in Western Washington, not much rain at all this fall, at least where we're at. But in most cases, starting in those fall months, we get a lot of rainfall patterns where it's just continuous rainfall, sort of, of medium intensity for, 3, 4, 5 months or more. And the soil saturation conditions are continuously changing. So if we think about a single event method where we're trying to model, the runoff coming from a certain land use area in a single event situation, a lot of the times the pre-existing soil condition is not taken into account. So when it rains, we're just assuming that it's like completely dry or something like that, and then it rains, then we have a certain runoff value. Well, continuous simulation goes, well, we need to know what the soil saturation condition is before that, how that changes over the course of the rainfall event, and then how that continuously is going to affect the runoff. And so continuous simulation is just overall a much better method for determining runoff, and you can actually generate flow frequency curves, which you're all probably very familiar with at this point. And so HSPF is what is the engine of WWHM 2012 and is what drives that continuous simulation method. And HSPF was developed back in the 70s, and that's what is used for continuous simulation. Now, I don't know how much of you actually know or have actually used straight up HSPF before. but it is not a fun. It's not a fun thing to use. Let's just say that. If you've ever seen an HSPF input file, it's not pretty. And so what WWHM 2012 does is it basically builds an HSPF input file in the software, but you're using a really nice user interface instead of using HSPF, where it's very, very specific how you have to build things out. There's not a lot of people who know how to use it, and so WWHM 2012 and WMSWM and our other continuous simulation software packages do a good job at doing that, and allowing you to build out those files and utilize continuous simulation hydrology. And so WWHM 2012 specifically relies on 60 plus years of rainfall data and 15-minute time step intervals for continuous simulation. Like I said, we're working on a rainfall update to get rainfall conditions through 2022, and of course there's also climate related things also factored into that. So we're taking our time to get that new data in there, so we have the updated precipitation data. And so I also like to talk about Department of Ecology's minimum requirements. If you've read through their stormwater manual, there's 9 minimum requirements. When it comes to modeling in WWHM 2012, we kind of care about runoff treatment, flow control. Wetlands protection is a big one. We get asked about wetlands a lot, and that's a very complicated process for determining wetland input volumes. And so we're kind of caring about minimum requirements 6, 7, and 8. And so, yeah, this is just an overview of them all. And so WWHM 2012 can really help you meet minimum requirements 6, 7, and 8. These other ones are more site control related. And so 2012 helps you meet 6, 7, and 8. And so minimum requirement number 6, that's runoff treatment. We think about the 91% filter that we can get in a facility such as a bioretention unit, for example. And if we use those in our project, we can then filter that runoff. Minimum requirement number 7 is flow control to help prevent those erosive flows and reduce the pollution in the streams. So what we're trying to do and some of you may have heard this spiel before, but I just like to talk about it, of course, because a lot of people, they kind of skip this concept of why we're actually using WWHM 2012. But essentially, if you have an undeveloped land patch, let's say you had 4 acres of forest, and then you developed 3 of those acres, and now you have 3 acres of roads or residential or whatever, impervious surface, and an acre of lawn. Well, the amount of flow and rainfall that we're going to get is going to be much different on the mitigated scenario or the developed scenario. We're going to get more runoff, right? And because we're having more flow, we're going to have more erosion, and so more of those erosion are going to go in our streams now. And so what minimum requirement number 7 is doing is we want to prevent these flows that have been identified to be these damaging erosive flows that takes erosion to a level that is dangerous and pollutes our streams. Some natural erosion is good, and it's just part of the natural cycle of what occurs in the environment. But too much erosion and too many erosive flows is going to cause some problems to the ecosystem. So we need to design detention retention facilities and mitigate this excess runoff that causes the erosive flows, and keep it from occurring, and come up with solutions. And that's what WWHM 2012 is doing. Is it allows you to then find ways to prevent those erosive flows from occurring, and that's minimum requirement number 7. And minimum requirement number 8, which is wetlands protection, which is to prevent the eradication of our wetland habitats and to keep the wetland input volumes for any given month within plus or minus 15% of what that wetland is used to. And that is the current requirement outlined in the Stormwater Management Manual. And so when it comes to flow control standards, you're probably familiar with these graphs here. This graph on the left shows when a facility has not been modeled to retain that additional stormwater runoff, and you can see that the facility fails for a lot of these identified flows, and so it's not allowed to exceed the amount of pre-developed flows that occurred for that erosive flow range. And then we see here when we designed a retention facility for that site, the facility now passes because it's able to keep those flows from exceeding it too many times. And the minimum requirement number 6, this is a properly modeled bioretention facility where it filters 91% of the water. And then this is an example of a facility that meets the wetland requirement. keeping within plus or minus 15 and showing a pass-fail over there. And so we are going to go into a bit of modeling here. Now, if you have a question, I'm going to go back to, are you going to post this session on YouTube after you're done? Yes, I will. So it'll go up. I'll send out an email showing with this session recorded. So you don't have to worry about missing anything. But if you want to ask questions now, you should do it now. So so I can answer them. But trying to escape my own PowerPoint here. Okay, so now I'm in WWHM 2012, and I'm going to show you how we maybe would meet some of these requirements in minimum time. So let's talk about minimum requirement number 7, which is flow control standards, right?